What is going on, everybody? Dan Tramte here, and welcome back to my tutorial series called Browser Noise. This is tutorial number 6, and one thing I want to do is a quick debriefing of the previous tutorials. Now, in the thing that we built, there were aspects of it that were relatively simple. There were also aspects of it that were relatively sophisticated, like the spectral analysis. And because of this, it probably seemed like there were points where I was trying to spoon feed you relatively basic concepts. And then there were some points where I was just like, boom, here's all the conditional logic. I hope you know what I'm talking about. Good luck. Here's the thing. I am trying to cater to a wide disparity of abilities in this environment called P5. And in doing that, yes, I'm trying to cater to beginners. I'm designing projects that target specific concepts. And when I do that, I'm going to go into great detail in those concepts. At the same time, I don't want to hold back from making these little web apps into projects that we're going to be proud of, right? I think it's pretty cool that we did spectral analysis in our first project. And I don't want to hold back from doing that. So if you're a beginner and it ever seems like I'm just sort of breezing through things that go over your head, please just code along with me, and rest assured, I will go over these concepts again. We will talk about conditional logic a lot. We will talk about arrays. And in fact, in this video, we're going to do for loops, and we're going to talk about why for loops are important. So I promise you, just code along. You don't have to always know what's happening, but if you stick with me, you'll get it. I promise. All right. Okay. So the purpose of a for loop is to do something over and over and over again that we would otherwise do manually. There's technically no reason to ever write a for loop. In fact, most people go their entire life without writing a for loop because they're not doing any programming, but that's a different story. You could probably get away with never writing a for loop in your sketches, okay? But here's the thing. You want to. It's a nice tool to have because there are going to be points in time when you want to make a grid, and that grid has 1,000, cells, and you don't want to manually write lines of code for all of those cells. You want to do that. You want to automate that. So think of for loops as a way to automate something that it would be really tedious otherwise, okay? Okay, I realize that I've been talking too much. Let's actually do this stuff. All right, so we are going to make some synthesizers. We're going to start with just one, and we're going to make a bunch later. So let's declare a variable, and we'll call it one synth. All right. And in our setup function, we are going to assign that one synth to a p5 object called p5.oscillator. So it's the same exact process as making a noise generator, except we're making an oscillator, and this is going to be a sine tone by default, okay? And the next thing we're going to do is we are going to call a method, and we've done this before. We're calling the amp method, and we're going to set it to 0.1, make it nice and quiet so it doesn't blast our ears. And then lastly, we're going to call yet another method, and this is going to be the frequency method, right? So we can set the frequency. By default, it'll be 440 hertz, by the way. Let's do something like 600. It really doesn't matter. It's just to show that we can change the frequency. All right, and then we gotta do the start method to get it going. And now when we press play, we should hear a tone. Good. All right. Now, as you might imagine, if I wanted two synthesizers, we would just make another one, right? Do the entire process over again. Two synth. just with a different name. We'll use 2synth. So in that case, I would copy and paste all this stuff that I just did. And for every other one, I would change the 1 to 2. Whoops. Oh, come on. 2, 2, and 2. And it's not going to sound any different. We need to change one of the frequencies, and let's just do something like 800. Doesn't really matter. All right, let's press play. Very nice. We have 2 tones, and one is at 600 hertz, and the other one is at 800 hertz. Fantastic. Again, I can make a third one, copy and paste, copy and paste. I can make a fourth one, copy and paste, copy and paste. And if it was just like 2 or 3 or 4, that would be totally fine. It wouldn't be a big deal. But if I wanted to generate 30 synthesizers, okay, it's not only about the fact that it would be tedious. Like, it's not a big deal. I can just grind it out and just copy and paste it 28 more times. That's fine. But the problem is that it becomes a huge chunk of code in our code box, and that gets a little unruly after a while. So we want to automate that. And so we're going to use 2 of our friends. Okay. I shouldn't say use our friends. That's a bad way to put it. But anyways, we're going to create an array. Okay. Remember, arrays, as I said, it stores a bunch of numbers, but it doesn't have to just store numbers. It can store something more sophisticated like entire objects. And that's what we're going to do here. So first, let me just get rid of the 2synth. Okay. Just because it's a little unnecessary. I'll keep the 1synth just to show you that how it differs from doing it generatively. So let's make an array of synthesizers. Not an array of numbers like we have done before, but an array of synthesizers. So we're going to declare a variable, and we're going to call it many synths. And I'm using a plural word because that's what makes sense when you're naming an array. Array contains many things, so we're going to call it many synths. All right. And let's just go ahead and comment all of this out. I just want to go through the entire logic of what we just did, making multiple synths, but doing that with arrays instead. And so let's do that. So the way we're going to add a synthesizer to an array is by calling the array like this, and then calling push. All right. Whatever we put in that push, open and close parentheses, is going to get added to our array. It's going to get pushed onto it. So in our case, we're going to push a p5.oscillator into that array. Great. So now the way we're going to access the oscillator that we pushed into the array is by calling many synths open and close brackets. We're going to put our index number. So at index 0, so the first synthesizer that we added into our array, that is at index 0. So many synths at index 0 dot, for example, amp 0.1. So we just set the first synthesizer in our array to an amplitude of 0.1. And likewise, many synths dot at 0 dot frec, we'll say something like 600. And many synths at index 0 dot start. Okay, notice everything is the same except we're using the index as to just refer to which synthesizer that we're using. So let's press play. We have a tone. Beautiful. Now, we're using arrays, but we only used it once. Let's do that again. Let's just see what it's like to push a second oscillator into our array. Now we should have an oscillator at index 0 and at index 1. So we can copy and paste all of this, and instead of calling index 0, let's do that at index 1, and frequency, let's use something like 800. Something didn't work. There it is. Perfect. Okay. Now, we're still doing this the tedious way, as you can tell. But so let's talk about how we can do this the automated way. All right. This is where our for loops come into play. If you remember what I said about for loops do things over and over again, so that we don't have to do things over and over again. The thing that we want to do over and over again is push more and more synthesizers into our array. So we want to do something like that looks like that, right? But the way we're going to do that is with a for loop. And the syntax is as follows. For, open and close parentheses, and then open and close curly braces. So whatever goes in between the braces is going to be the thing that happens over and over again. But the question is, how many times? So that is going to be determined inside our parentheses. And there's a convention that you should get used to. Let I equal 0, I is less than, and then the number of times that you want to do something. In our case, let's have our goal be 25 times. We want to push 25 synthesizers into our array. So I'm going to put 25 and then semicolon I++. I++ is an incrementer. It means that it's going to add 1 to itself every time it gets run. So let's think about this. The first thing that happens is we declare and assign a variable I to 0. So I equals 0. Then there's a condition over here, right? Is I less than 25? Yes. So in that case, we're going to run the code here. And then after that, I think, it gets incremented up to 1. All right. So the next time through the loop, it sort of skips this part. It goes to here. I is 1, right? And 1 is less than 25. Yes. So run this code and then increment our I to 2. Now, I is 2 and 2 is less than 25. So run our code and increment up to 3. Good. So it does that 25 times. And on that last time, when it says, when this increments up to 25 and it's 25 is less than 25, it says, wait a minute, no. So it doesn't run the code and it stops the for loop. So that's how the for loop works. Now we can press play. It should work the same way. But we have now, when I press run, an array filled with 25 synthesizers. The thing is, we're only accessing the first synthesizer, right? The one at index 0. So what we're going to do is actually copy and paste all of this into our for loop. Boom, like so. So what's really cool about this is now these 3 lines of code are going to be run 25 times. So in the same way we built 25 synthesizers and stored that into our array. But the problem is we're still only looking at the first synthesizer in the array, and that's a bit of a problem. What we want to do is access the 0th, or the first one, the second one, and the third one, and the fourth one, etc. until 25. Now, here's the thing. We can type that out, 0, 1, 2, etc. Or we have something that is incrementing from 0 through 25, or 0 through 24 technically. And that is our variable I. So if I simply pass in our variable I, which is incrementing, we're going to, in the first round through this for loop, that I is going to be 0, and we're going to set many synths at index 0.amp to 0.1. We're going to set many synths at index 0.freq to 600, etc. But then the second time through the loop, I is going to be 1, right? It's going to be a value of 1. So we can use that, and that then many synths at index 1.amp is going to be 0.1. So now it's going to work. This might be loud. I'm just going to go ahead and add a 0 in front of that. The reason why it's loud is because we just made a bunch of oscillators all at the same frequency. So one thing we can do that's cool is we can just use that I in a bunch of different creative ways. So like 600 plus I times 10. Okay, think about that. In the first time through the loop, I will be 0. So the first synth that we are going to make, or the frequency of the first synth that we're going to make is 0 times 10 plus 600. So that's going to be 600. The next one is going to be 1 times 10 plus 600, which is 610. The next synthesizer is going to be 2, so 2 times 10 plus 600, so that's going to be 620. So we're going to have 25 different oscillators, and they're all going to have different frequencies. So let's press play. That sounded a lot cooler than I expected, actually. So one thing I want to do is I want to add a little bit of randomness, okay? So 400, let's, instead of just doing some multiple of 10, let's do something like plus I times random of 1 and 1,000. If you can't see that, 1,000. So random function is going to return a number between 1 and 1,000, and that all of those are going to be added to, multiplied by I, and then added to 400. Let's hear that. Uh-oh. Missing. Yeah, I just missed that. Let's try that. Whoop. It sounds like a bell. It's an enharmonic sound, so it's going to sound like a bell. Fantastic. Cool. All right. I think that's enough for today. I might come back to this with a short follow-up tutorial, but we'll see. We'll see. I'll be back. See you in the next one.